2-week lab that we're doing today, so you do not have a lab report due next week. This is going to be a 50-point lab though, so if you look at your syllabus, this looks like count doubles, so make sure that you do a good job writing your lab report and paying attention and all that fun stuff. Anyway, this week we'll be starting the conversion of alcohols to alkyl halides. It's going to be so much fun, I promise. Okay, so this one we've done, if you have your sheet, you can follow along with me. We're pretty much going to go along through that. So, as it says on your sheet, if you look at your pre-lab then, we're going to react to it with, it says either hydrochloric acid or hydrobromic acid. You can use either one. And if you looked on your sheet, it said that it's possible for your mechanism to occur as an SN1 or an SN2 mechanism. So, which of those two could you see a molecular rearrangement occurring in?
SN1.
SN1, right. So SN2 is going to have that transition state. If you remember from your quiz last week, you had to draw a transition state in there. So that's going to be the key to that. So you only are going to have a rearrangement with SN1 typically because it can form that carbocation. Okay, so this is a good note. We're not using hydrobromic acid directly. So can somebody tell me how we're going to generate it in our experiment? Good. All right. Yeah. So we'll be using sodium bromide today, and you'll be using that to generate your hydrobromic acid.
What is sodium bromide going to react with? Mainly sulfuric acid. That's what to do. Move away from so make sure you explain where you're coming from. By knowing mechanism, you're writing it up.
And I know I shouldn't have to say this, but I'm going to say it anyway. If we're dealing with strong acid, please be careful. Don't burn yourself. If you do get something on you, you can come blot it off with a paper towel, and then you can wash it. If there's any left on it, you can wash it with some base, or just wash it under lots of water. Or if you just freak out and come get me or Sonia, we'll help you out too. Okay. All right. So, questions now. Which one of these do you think is going to be most likely to go through SN1? A little bit louder?
2-pentanol.
Good. Okay, yeah. So why do you think, somebody tell me, why do you think it can be 2-pentanol?
Because it has great leaving group
Okay.
rearrangement.
Alright, so did y'all hear what Sonia said?
No.
The carbocation, if we use 2-pentanol, when you form the carbocation under an SN1 mechanism, you can have the most stable that can occur there. So which one do you guys think would occur through SN2 then? There you go. The second choice that you have left there. Why? Bingo. Okay. So make sure that if you look at this and you said it's primary, and if you say it's going to fall at SN2, then we're not going to see a carbocation. And if you remember from when we talk about our mechanisms, SN2 is most likely to occur with a primary alcohol that we're going to be working with today.
Just to review, can you show hydroxide leaving on its own?
No,
No, you have to add water
have to add water and then leave it.
and pronate it.
And that's a good point. I noticed on quizzes too, make sure when you're doing this in the class or in the lecture, stuff isn't just magic chemistry. I know it looks like that, but if it happens for a reason, so in this case, hydroxide doesn't just decide to pop off on its own magically. I don't know why. So you got to be able to show what happens, show that water's going to come in, protonate it, it's going to leave, things like that. Okay, so how many products would you expect for each one? Okay.
4 on the SN1.
Hear your different answer. How many people say 2?
Total or for each?
For each one?
For each.
Okay.
1 and 2.
Can you repeat the question? Okay, how many products would you expect? Yeah, 1 propanol each.
1.
Why is it 2? You have a hydride strip and an SN2 So SN, okay, so we said 1 propanol is SN2. That's out of 10. There is no carbocation forming, therefore there's no rearrangement. There's no rearrangement, there's only 1 carbon.
Hey, yay!
Okay.
I said 1.
So 1?
1.
Basically,
Toot my own horn. Where you been? Where you been?
Hold on, we're getting to the process.
We were asking.
Where would the bromine go? In the middle, right?
With us?
So, the note that
With
says
us?
there, basically, your secondary fluid is going to secondary to tertiary product. In this case, there's nowhere in the molecule that can make it tertiary. But even though it's going from secondary to secondary, it's still possible, and that's how you will get the bromine.
When you move the bromide into the middle on the first carbon, would it make the bromide over into the symmetry?
That's for you to decide which one will work. So right now, what you're doing is hypothesizing, and you don't know for sure that this will have two products or one product. That's your point of the lab to figure out which mechanism. And so remember, last point, half of you will only work on one substrate and the other half will work on others, but this is a 50-point lab report, which means you're going to talk about both in every detail, the mechanisms for both.
Okay. So this experiment is actually very straightforward. If you look on your handout, this is just pulled straight from there. So you're going to start out, you're going to use these flasks. We've set everything that you need up here in front of the lab. So you can see these nice plastic bins. You're going to be able to get most everything that you need from up here. So using one of these reaction flasks that's going to be found up here, you're going to add 3.5 grams of sodium bromide, 6 milliliters of the sulfuric acid there to one of these round bottom flasks. So like I said, make sure that you don't use the one that's in your drawer because that one's a lot smaller and it's not going to be able to hold everything. So just come up and use one of these. One of the key things in this is sodium bromide is, for lack of a better word, just chunky. So you need to break it up and make sure that it's broken into smaller pieces so that way we can see our reaction is going to happen a little bit faster when we start doing some reflux in here. And then we'll tell you which ones we want you to do. Like she said, half of you will do the pentanol, half of you do the propanol experiment, and then next week we'll make sure that you have all the data for everybody when you leave. So that way, if you do pentanol, you'll get somebody else's propanol data at the end of next week then. So you also need to make sure that you add Bowling chips because we will be doing distillation and reflux today. So that'll keep it from bumping. So you don't want anything shooting out of your apparatus there. And we'll be using the sand bath to do a reflux there. So, all right. Okay, so reflux. Can anybody, first of all, can anybody tell me what distillation is? What's the purpose of doing a distillation?
Separate.
Okay, the purpose of distillation is to separate your components necessarily. Not necessarily purifying, but the main purpose is to separate it. To get one product over here, one product over there. Reflux is a very similar setup in that you're going to do things like you would do a distillation. However, we're going to have a closed system so that way we don't lose anything during a reflux. You want to be able to add heat to your reaction and just let it sit there, keep adding heat to it without losing any of your products or having anything separate out. So as you can see over here, this is going to be what your setup for the reflux look like, and I have it drawn on the board behind here. But as you can see, you're going to use your round bottom flask. You've added everything in the bottom of it with your boiling chips, everything you need. You're going to be able to connect it. You're going to connect this like it's shown up here on the board, and then out of the sides, you're going to have two little plug, or it looks like little prongs sticking out. You're going to put tubes. There you go.
Can you move my keyboard down?
Reflux only needs 2 pieces of glass.
Thanks.
And it's simple installation. Basically, you have a round bottom.
Okay, so we've got a round bottom plugged in directly
Look like
to
a
our
ball.
condenser here. So one thing also to note is you can see how this fits in here. We have some stopcock grease in the back for every joint that you make. So just whenever these things come together, put just a little bit of grease on there. And remember, a little bit goes a long way, so don't go spurting this everywhere and getting it all over your hands because it's never going to come off. So just make sure you just put a little on there, and it's going to help hold this seal in when we're doing the reflux. Right?
You're in the last class, so these are pretty
Okay, that's fine. All right, and then also you notice these two little things sticking out of the side. This is going to be where you're going to put water into the condenser. Now this is also where I talk about magic chemistry. I know this may not make sense, looks like it doesn't make sense, but trust me, it's going to work. We're going to put water in here. You're you're gonna have this hooked directly into the water line in the fume hood. Turn your water on, it's gonna fill up to here. Have another tube coming out of this part and out the top, draining into the sink. So you're gonna put water in at the bottom, and it's gonna come out at the top. So whenever you're doing this experiment, remember, water goes in at the bottom, comes out at the top. Whichever point is lower is where the water goes in, water comes out at the top then. Good, okay, good, all right. Just making sure that everybody, because if not, if you put it the reverse way, it's just not gonna do anything.